Okay, let's talk about that feeling. Something is just off with your React app. The UI stutters, clicks feel a little laggy, and you just can't seem to pin down why. Well, today, we're going full-on detective to hunt down the silent performance killer that plagues so many React applications. We're about to crack the case of the unnecessary re-render.
You know exactly what I'm talking about, right? Your app works, but it just feels broken. There's that tiny delay after a click, or maybe a stuttering in an animation. It's like a death by 1,000 cuts for your user experience. You've been staring at the code for hours, but the culprit isn't some obvious bug. It feels more like a ghost in the machine.
And here it is. This is our prime suspect: unnecessary re-renders. It's kind of like having an employee who does their job perfectly, but then redoes it 10 more times, just in case. React is an absolute beast. It's like a Formula One engine, but we're accidentally forcing it to just idle in traffic. So our mission is to figure out why and finally put our foot on the gas.
Every good detective needs a plan, right? So here's ours. First, we're going to debunk a common myth about re-renders that trips a lot of people up. Then we'll follow the evidence to find out what really triggers them. We'll get out our forensic tools to trace the source, uncover a sort of inside job from JavaScript itself, and finally learn the secret weapon: memoization. But we'll end with maybe the most important lesson of all: knowing when to just close the case and walk away. All right, first things first, let's bust a myth. There's this piece of, common knowledge about re-renders that is just plain wrong, and honestly, it sends even really senior developers down the completely wrong rabbit hole. So let's clear the air.
Let's be crystal clear about this. A component does not re-render because its props changed. That's the symptom, not the disease. The real trigger, the one thing that kicks off this whole chain reaction, is a state change in a parent component. When a parent re-renders, it takes all of its children with it for the ride, no questions asked. This is the fundamental truth you have to grasp to solve this mystery.
Okay, so if the parent state change is the trigger, what's the underlying principle here? Let's zoom in on the core mechanic that really drives every single render in a React app. Getting this right is like having a key to the city of performance.
So here's how React thinks. A render is really just taking a snapshot of what the UI should look like based on the current state. When that state changes, it takes a new snapshot and basically plays a game of spot the difference with the old one. The magic of React is that it's incredibly fast at this game, and it only touches the parts of the actual screen, the DOM, that absolutely have to change.
And this is why that whole waterfall effect happens. React has one prime directive: never, ever show a stale UI. It has no way of knowing for sure if some distant grandchild component is secretly relying on that parent state. So, to be safe, it assumes the worst and just re-renders everything downstream. It's a feature, not a bug. It guarantees correctness, but yeah, it can come at a cost.
Okay, so we know the principle now, but how do we actually see this happening in our own code? Well, it's time to open up our Detectives toolkit and learn how to trace these renders right back to their source.
First up is our magnifying glass. In the React Dev tools, there's this simple little checkbox: highlight updates. Turn that on, and your app will just light up like a Christmas tree. Every single component that re-renders will flash. It is the quickest, most satisfying way to see exactly where the action is happening, and more importantly, where it probably shouldn't be.
But when you need more than just a visual clue, when you need the actual DNA evidence, you reach for the profiler. This thing is the forensics lab. You just record an interaction, and it gives you a full report, telling you not just what rendered, but the exact, undeniable reason why. No more guesswork. This is your source of truth.
So you run the profiler, and it gives you a lead. It says props changed, but you look at the props, and they look identical. You're staring at two objects that look exactly the same, yet React swears they're different. What is going on? Well, it turns out the call is coming from inside the house. The problem isn't React, it's JavaScript.
This is a concept called referential equality, and it's fundamental to how JavaScript works. Think of it like this. For a number, JavaScript asks, what is your value? But for an object, it asks, where do you live? It compares their home address in memory, not the furniture inside. So if two objects don't share the exact same address, as far as JavaScript is concerned, they are complete strangers.
And this, right here, is the smoking gun. An empty object is not equal to another empty object. Just let that sink in for a second. This means every single time your component renders, any object or array or function that you define right inside of it is a brand new thing with a brand new memory address. So to React, it looks like a completely different prop than the one it got last time.
This is exactly what happens when React compares props. For the number 5, it's a simple value comparison. 5 equals 5. Easy. But for the object A1, even though it looks the same to us, React is comparing those memory addresses, which are different every time. And that's the trigger. This is the real reason why your seemingly identical props are causing all those re-renders.
So, if creating new objects and functions on every single render is the problem, the solution must be to, well, stop creating new objects and functions. We need a way to preserve the memory address of our props across renders so that React sees them as the same thing. This technique, this solution, is called memoization.
And here is your toolkit for the job. It's basically a two-part system. First, you tell a component to be on guard by wrapping it in react.memo. This tells it, hey, check your props before you re-render. But that's useless if the props are always new, right? That's where useMemo and useCallback come in. You use them in the parent to freeze your objects, arrays, and functions, making sure they keep the same memory address. So, reacts.memo builds the wall, and useMemo and useCallback supply the stable bricks.
So now we have our culprit, and we have the tools to bring it to justice. But this is where experience really comes into play. The best detectives know that not every lead is worth chasing down. Just because you can optimize something doesn't always mean you should. This is the professional's code of conduct: profile first, optimize second. You have to remember, React is incredibly fast. For many of your components, just re-rendering is actually cheaper than running all the checks for memoization. Applying these tools everywhere is just going to make your code more complex for no real gain. Use the profiler to find the real fire, and then use these tools as your fire extinguisher.
So here it is, the entire process in one sentence. Trace the render, find the cause, and then fix it only if it matters. Don't guess. Use the profiler. Identify if it's a state waterfall or a reference issue, and most importantly, ask yourself if it's a real performance bottleneck before you start adding complexity. This is the path to truly fast applications.
And with that, case closed. You now have the mental model to see past the myths and the tools you need to find the truth. You understand React's core render loop, and you know how to use memoization with precision. So the next time